What if one of the most common appliances in your kitchen today, something you use daily, actually came from a completely random accident? A melted chocolate bar in a scientist's pocket during wartime profoundly changed everything we know about cooking today. This is the story of an invention that nobody planned, predicted, yet it transformed how billions of people prepare food daily. It's a story that begins not in a kitchen, but in the shadow of World War II, where survival depended on innovation. The year is 1945, and the world is still reeling from the devastating aftermath of a long and terrible war. In laboratories across America, engineers and scientists tirelessly work on technologies meaning victory or defeat. Radar systems became critical to the Allied war effort, detecting enemy aircraft and ships from impossible distances. At the heart of these systems was the magnetron, a vacuum tube generating powerful microwave radiation. At Raytheon Corporation in Massachusetts, Percy Spencer was deeply involved in improving these magnetron systems. Spencer was no ordinary engineer. Despite having no formal education beyond grammar school, he was an expert. Born in poverty, orphaned at 18 months, Spencer educated himself through sheer determination and curiosity. He learned about electricity by studying at night while working at a paper mill, making his expertise invaluable. Day after day, Spencer worked in the radar laboratory, surrounded by humming equipment, glowing vacuum tubes, and the faint ozone smell. The magnetrons he tested generated microwaves at frequencies around 2.45 gigahertz, incredibly powerful energy. Then one ordinary afternoon in 1945, something truly extraordinary happened completely by chance. Spencer was standing near an active magnetron, running routine tests, when he felt something strange in his pocket. The chocolate bar he'd been saving had inexplicably turned into a gooey, melted mess right there. Now, most people would have simply cursed their luck and thrown away the ruined candy immediately. But Percy Spencer wasn't most people. His mind immediately began asking questions about this phenomenon. Why had the chocolate melted there? The room wasn't warm, nor was he near any other heat source. Could the microwaves from the magnetron have caused this strange melting? It seemed impossible, yet there was no other explanation. Spencer's curiosity was ignited, and he didn't rest until he understood it completely, planning an experiment. Spencer brought popcorn kernels into the laboratory, placing them near the active magnetron and watching carefully. Within seconds, the kernels began to heat up, then suddenly they started popping, scattering across the floor. His colleagues watched in amazement as microwave energy cooked food right before their very eyes. But Spencer wasn't satisfied yet. He needed more evidence and crucial data from further experimentation. The next morning, he brought in a raw egg, placing it in a kettle with a hole cut in its side. He turned on the equipment and stepped back, observing the egg from a safe distance. The egg began to tremble and shake as microwave energy penetrated its shell, heating the liquid inside instantly. One of Spencer's colleagues leaned in closer, curious about what would happen next with the egg. And that's when the egg exploded, covering the unfortunate engineer's face with hot yolk and white. The microwaves had cooked it so rapidly that steam pressure built up inside, causing the explosion. Despite the mess, Spencer was thrilled. He'd just discovered something truly revolutionary in the lab. Microwave radiation could cook food from the inside out, far faster than any conventional methods before it. But understanding a phenomenon and turning it into something useful are two entirely different challenges. Spencer knew he had a long road ahead, facing many challenges in this scientific endeavor. He began conducting systematic experiments, trying to understand exactly how microwaves interacted with different types of food. Water molecules were key. When exposed to radiation, they vibrate billions of times per second. This molecular friction generates heat almost instantaneously, making foods with high water content heat fastest. Spencer realized he needed an enclosed metal box containing and directing microwave energy more efficiently. Metal walls would reflect microwaves, creating a concentrated cooking chamber, a critical design element. He enlisted Raytheon's engineering team to construct the first prototype of the eventual microwave oven. The initial design was crude, a metal box the size of a small refrigerator with a magnetron mounted on top. There was no turntable, no digital controls, no sophisticated safety mechanisms present yet. Testing this prototype was both exciting and dangerous, as nobody fully understood the long-term effects. Spencer and his team proceeded carefully, experimenting with power levels, cooking times, and food types. What they discovered was remarkable. Food, normally taking an hour to cook, could be heated in minutes. A frozen dinner could be thawed and cooked in the time it took just to set the table, a huge breakthrough. The implications for commercial food service were enormous, enabling unprecedented speed for meals. Raytheon immediately recognized the commercial potential of Spencer's discovery, understanding its market. In 1946, a year after that melted chocolate bar, the company filed a patent for a cooking oven. The patent described using microwave frequency electromagnetic energy for cooking and credited Percy Spencer as inventor. Securing a patent was only the beginning. Turning this laboratory curiosity into a marketable product posed challenges. Magnetrons used in radar were expensive to manufacture, consuming enormous amounts of electrical power then. The first commercial models would need to be substantially engineered for consumer use, requiring many changes. In 1947, Raytheon introduced the world's first commercial microwave oven, the Radarange. This first model stood nearly 6 feet tall, weighed 750 pounds, and cost $5,000. Roughly equivalent to $70,000 today, it was an incredibly expensive piece of technology. The Radarange was marketed primarily to commercial establishments where speed and efficiency justified its cost. It required its own dedicated water cooling system, plumbed like a washing machine with lines running in and out. Early adopters were fascinated but cautious, concerned about invisible radiation and potential harm from eating. Raytheon invested heavily in studies and demonstrations, proving microwave cooking wasn't dangerous. The microwaves heated the food but didn't fundamentally alter its molecular structure, ensuring safety. Despite reassurances, widespread adoption was slow. The technology was expensive, unfamiliar, and intimidating. Few imagined this massive industrial machine would shrink to become a standard fixture in every kitchen worldwide. The real challenge wasn't just technical, it was economic, proving a substantial hurdle for this new device. Costing $5,000 in 1947, it was roughly equivalent to $70,000 today. Only the wealthiest restaurants and luxury ocean liners could truly afford such an expensive device. Even those who could afford it weren't entirely sure what to do with it, lacking guidance and purpose. Chefs trained in traditional methods feared speed would compromise quality, texture, and flavor of their dishes. The very speed that made it revolutionary also made it highly suspicious to professional chefs. Meanwhile, Raytheon faced another problem. The magnetron tubes were expensive and notoriously fragile. Each unit needed constant maintenance, specialized training, and dedicated electrical circuits for operation. For most businesses, the investment simply didn't make sense, despite the innovation's brilliance. Percy Spencer continued to refine his invention throughout the late 1940s, but progress was painfully slow. Sales were disappointing. Critics dismissed the microwave oven as a wartime curiosity with no real future. Some even suggested Raytheon abandon the project entirely and focus on military radar systems instead. But Spencer believed in the technology, knowing if the price and size could shrink, it would find its place. The question was whether Raytheon would have the patience and resources to wait for that day to arrive truly. Otherwise, the invention would fade into obscurity, like so many other promising innovations. The turning point came in the early 1950s when Raytheon acquired the Amana Refrigeration Company. Amana had expertise in manufacturing consumer appliances and access to distribution networks for households. This acquisition proved crucial, giving Raytheon the infrastructure to transform the curiosity into a product. Throughout the 1950s, engineers worked relentlessly to miniaturize the technology for wider use. They developed smaller, more efficient magnetrons, redesigned cooking chambers, and simplified controls for consumers. Gradually, over years of incremental improvements, the massive radar range began to slowly shrink. By the early 60s, countertop models were finally becoming feasible, though still prohibitively expensive. In 1967, nearly 20 years after Spencer's discovery, Amana introduced the first truly affordable countertop model. Priced at $495, it was still expensive, but manageable for many middle-class families. This was no longer a luxury item for restaurants, but a consumer appliance designed for American kitchens. Affordability alone wasn't enough. Americans still didn't know why they needed a microwave oven truly. What problem, exactly, did this new appliance solve for families? They had other working appliances. Amana and other manufacturers faced a massive education challenge, needing to teach people. They had to teach people not just how to use microwaves, but why they should want them initially. Marketing campaigns emphasized speed and convenience, targeting busy housewives with a promise of ease. The message was clear. The microwave oven would save time, reduce effort, and make life easier for everyone. Still, skepticism remained, and safety concerns persisted despite numerous studies proving no health risks. People worried about radiation leaks, uneven cooking, and invisible waves altering meals in unseen ways. The technology was simply too new, unfamiliar, and too different from everything that had come before. The breakthrough came not from advertising or price reductions, but from changing lifestyles dramatically. As the 1970s progressed, American culture shifted dramatically, accelerating the pace of life. Frozen food became ubiquitous, fast food chains proliferated, and TV dinners became staples. People wanted convenience, and they wanted it now. So, suddenly the microwave oven made perfect sense. By the mid-70s, microwave oven sales began to climb exponentially, becoming increasingly common. Manufacturers introduced new features like digital timers, power settings, and rotating turntables for even cooking. Prices continued to drop as production scaled up, and competition increased for the technology. The technology Percy Spencer stumbled upon in 1945 was finally achieving mass-market success, truly. Food companies adapted quickly, developing products specifically designed for microwave cooking and its new requirements. Entire sections of supermarkets were suddenly dedicated to foods prepared in minutes using this revolutionary appliance. By 1975, 1 in 10 American households owned a microwave oven, growing steadily. By 1980, that number had tripled. By 1990, over 80% of homes had one. What had taken decades to commercialize became ubiquitous in barely 20 years, an astonishing transformation for all. Percy Spencer, meanwhile, continued working at Raytheon until his retirement from the company. He never became a household name despite inventing an appliance appearing in hundreds of millions of households. He held over 300 patents, but the microwave oven remained his most enduring legacy and creation. He died in 1970, just as his invention was beginning its truly explosive growth across the globe. He didn't live to see the full impact of what he had discovered, a true scientific tragedy. He never saw microwave popcorn become a movie night tradition or frozen burritos a staple for a generation. He discovered something revolutionary, but he left before the revolution truly took hold and changed everything. The story of the microwave oven raises profound questions about innovation itself and its unexpected beginnings. How many other revolutionary discoveries began with similar accidents, with experiments going right? How many potential breakthroughs are we missing because no one notices the unexpected result and investigates